Okay, I'm here on board the Honeywell G450 demonstrator with Jim Andersen from Honeywell's UOP division, who's going to tell me about biofuels. How did the flight go over here?
It was very uneventful because and that's kind of our goal on this. We produce drop-in replacement fuels, so you really don't know any difference with whether you're flying on biofuel or flying on regular fossil fuel.
Can you tell us something about the importance of biofuels to aviation?
Well, we see a lot of potential with biofuels to be able to, one, reduce the amount of CO2 emissions. So from a greenhouse gas perspective, it's a key enabler. There's potential to achieve between 60 to 80% reduction in greenhouse gas emissions with biofuels. And the other key advantage is to help reduce the dependence on fossil fuels. So what we've been looking at is producing these drop-in replacement fuels. We're just about to see the ASTM certification of the hydroprocessed renewable jet fuel. And that's expected by July to be completed. And once that's completed, we do see good potential for moving forward with producing biofuels in large commercial scale.
Okay. And what's the price point compared to Jet A1 or kerosene?
Well, right now we've been producing the jet fuel in small scale facilities. And so the cost of it is quite high today relative to conventional jet fuel. But going forward, we see as we increase the economies of scale, the feedstock cost will come down, and feedstock cost is about 80 to 90% of the cost of production for the biofuel. So that's the key point of it. The cost to actually process it, convert it over into jet fuel is comparable to the cost for converting fossil fuels into jet fuel or crude oil into jet fuel. So it really comes down to the feedstock. Right now, for small scale, what we refer to as second generation feedstocks, they tend to be higher than what crude oil is today. And as we see those costs come down with improvements in the crop and harvesting, as well as purification of those feedstocks, and we're expecting that the prices will come down. We've seen some decreases already, and there's been a lot of technology improvements there. And as we get the economies of scale for full commercial production, we expect then that the biofuels will be competitive with crude oil derived feedstocks.
Okay, and the biofuel that's used on this jet at the moment, what's that made from?
The material, the original starting material for this is Camelina oil. Camelina was grown in the northwest area of the U.S. It typically is grown as a rotation crop in wheat fields, so it does not compete with food crops. It's something that they typically in wheat fields, they will have 1/4 of their fields will be left fallow for a year, and so they can plant this in instead of allowing these weeds to be in that fallow field that displaces the weeds. And then, so basically about 25% of all the wheat farmland in the U.S. could be converted to producing Camelina oil.
Wow. And what about algae for biofuels? Do you see that as the third generation solution?
Yeah, the Camelina is one of what we refer to as a bridging feedstock for second generation fuels. Beyond that, one of the advantages of algal oil is that you get very high yields of algal oil per acre, and so there's good potential, and that'll continue to increase the availability of natural oils for converting into biofuels.
Okay. My final question here is: we've had the interim agreement, interim sort of certification. What's now the biggest challenge for biofuels?
Well, that's been a big milestone for us, is to get that certification, because prior to having certification of the fuel, you really can't get refiners and producers to be investing, hundreds of millions of dollars in producing, in installing plants that can produce the biofuels on large scale. So now that we're just about to see the official certification being given by ASTM, that will enable those investments to go forward. And we do have customers that are interested in building plants, and I think over the next couple of years we're going to start to see more and more of those plants start to materialize. And in doing that, that helps then to grow the whole supply chain from the farm fields all the way through to pre-processing and refining into jet fuel.
Thanks so much for your time. Thank you.
Okay, thank you.